This is the Arduino based drone that we've been making for the past few weeks. Now, in my last video, I told you that we are not going to use this frame for now because I broke one of the coolest motor, and without this one, we will not be able to complete this project. I have already placed the order, but unfortunately, it will take time to reach me. So in the last video, I told you we will switch the frame to a bigger one using this one because I had this gear system and the motors for it. So we will be proceeding the final video of this project using this configuration, this drone. And I would like to tell you guys that this will be the last video for this project for now, because in this video we will tune the PID and also have a stable flying drone for this video. And we will not be able to implement the altitude hold feature for now. This I will continue this in about 1 or 2 months, but for now I would like to switch project because I've been working on a RC plane that uses Arduino again. I have already made the tail for the RC plane using my 3D printer. This is printed in my newly made 3D printer that I will share the experience with you guys, and you can see the printing quality. It's very good compared to my old 3D printer. For this project, I have already explained to you the connection, or rather you will find the circuit in my website. If you're watching the video if you're watching this video on the day of release, you might get it the same day or on the next day. And yes, so let's upload the code. I will explain to you briefly the code because you will get the code in my website. The links will be in the description below. So let's just go through the code and do the PID tuning for this drone. Now I have already connected my drone to my PC. I now move to the multi-way code. You will find this code in my website. The links will be in the description below. First of all, when you open the screen, you will see this screen. Now I move to config.h and I will check some parameters in this code. First of all, I check that the quad X is uncommented. If it is comment, it will be disabled, so I uncomment it. Then I move to main throttle. Now, because we are using a brush motor and a homemade ESC for the brush motor, the main throttle will be 0 because the brush motor uses increase the speed using a duty cycle from 0 to 100. So we will leave this one to 0, but the maximum throttle we will leave to 2000 because this will be the this will be the 100% duty cycle. So we leave that to 2000, and the main command also should be 0 because we don't want our drone propellers to spin when it is not armed. And next, we need to check if we have the DJI 521 sensor enabled. And then I move down to the receiver section. This is the RC system, and I make sure that we have the NRF24l01 enabled here. So that's what you need to do for the code. The rest you need to keep the same. You will have the code in my website. The links will be in the description below. So then you just select your board and just upload the code to the Arduino. Now I open the multi-way WinGUI. This also you will have the download links below in the description. So I open it. Once open, you will find this screen, and then hit connect. Now for the parameters, if you have uploaded the fresh code, you will see that the roll will be 3.3, pitch will be 3.3 for the P. This is the PID values that we will change in a while. For now, I go to real-time data, and then I see if my sensors are working. You can see that if I move it, you can see that we are getting the values in the multi-variant UI interface. So now I have also my transmitter. For now, I'm still using this one because I have not made a better one for now. In my next video, I will be making that also. And if you can see that if I move the throttle, you can see the throttle value is moving, and also the yaw value. For now, you have to place your quadcopter in a flat surface. Make sure that it is a flat surface. Then you need to click on calibrate accelerometer, this one. Just click on calibrate accelerometer and click OK, and wait for 5 seconds for it to calibrate the sensor to make sure that this will be the initial position of the sensor. Also, now once you have done this, I move to RC control settings, and I make sure that when aux1 is low, it will be in the angle mode, and when aux1 is high, it will be in the horizontal mode. Now then I go to the parameters. Now this is the PID tuning process. First of all, when you will upload the code, you will see that the roll will be at 3.3, and also the pitch will be at 3.3. Okay, let me just try it with that, and then I write the settings. Okay, but this will not be the actual PID value that we will be using. First of all, you need to put everything to 0. So I let everything to 0. I just write the setting, and if I now once I write the setting, I will just go to real-time data, and I will connect the battery, and then I turn on my transmitter. So once I turn on my transmitter, I make sure that the drone is on a flat surface, and then in the transmitter, you can see it here. In the transmitter, I keep the throttle. This is the throttle, and this is the yaw. I keep the throttle to minimum, and then move yaw to maximum. This will arm the motors. You can see in the GUI interface, the light has turned on, so we have already armed the quadcopter. So once if I increase the throttle, the speed will increase. So the first thing that I need to check is when I increase the speed and I move the quadcopter, I should feel that the quadcopter is fighting against my move. So if I move it like this, you will see that these two motors will increase, and if I move it like that, you will see that the other two motors will increase, and if I move it here, the two front motors will increase, and same for this. Now this means that our drone is working and it is fighting with the orientation that we are changing. Okay, so now for now we have to increase this is not the best way to do it. The best way to tune a PID is using a simulator to input the parameters of the drone, of the control of the system. Then we will get the best value for proportional, integral, and derivatives of the system. But I like to do it using the trial and error. But the way I like to do it, I like to keep the D to 20 for pitch and roll, and then For the eye, you can leave it to 0, or I will just increase it to 0.010 for pitch and roll. So I will increase roll to 5 for now, 0.5, and also for pitch for 0.5. Okay, then I write the setting. I click on write settings. Once the setting is written, I disconnect it first. And then I remove my cable, my USB cable, and then I shall do a testing to see how it is performing. Now I don't have a proper control with this transmitter again, but I will just try to see how it performs. So you could see that we have oscillation in both axes, so the pitch and the roll, so we have to tune that again. So I connect the drone again. Once connected, I will increase the roll and the pitch by 0.1 and 1 again and again, and test if it has reached its stability. So I do that again. I'll increase it to 6 and this to 6, and I will check if these have some more stability. But after doing some PID tuning, I'll increase the roll to 1 and the pitch to 1.3, and the D to 34 for now. To 34 for now, and for the pitch I will increase it to 37, and the rest I will keep the same, and I'll just try the setting. I disconnect it and do the test again. So I'll just disconnect it and let's do the test again. So I don't have anyone to shoot that for me, but I'll try to capture that in the camera. But also with the transmitter, I'm getting some difficulties to control the drone, but I'll try to show you how it's performing. But you can see that the roll, if I move it, you can see the rolls are working, the pitch also is working. So we do have some good control. So I'll just try to show you how it's stable now. So it has become a little more stable. Now we had a little more vibration that we need to reduce, so I'm gonna tune the PID a little more. So let's do that. So let's try that again. You can see that the drone is quite stable now. Drone project is completed now, and I'm very glad that our drone is working and we've been making this together. So if you guys want to make this, you can download everything. You can download all the files, and also for the list of components, you will have that in my website, and also for the codes and all. But I must warn you for one thing, that the PID control is not a one-day tuning process. It's a very time-consuming process. Now I have to come at these values, to come that at this stability. It had took me a lot of days. I have shown you this in one video, but it does take a lot of days to tune the PID. Now your PID values will not be exactly the same as mine. You might need to change it a bit because it might be close to my values, but if you make this drone, it might be close to my values, but I'm sure you will have to tune it a little bit more if you're making this drone yourself. But I'm pretty happy with the result that I have got. I hope you guys have liked this video, and I shall see you in my next video. And if you guys have not yet subscribed to my channel, please do so. If you like this video, put a like, and I will see you in my next video.